Thank you very much. My name is Gustavo Ayres de Castro. I'm presenting some work here that was done jointly with some colleagues from the SAP Global COE for Data Science, particularly a couple of them very high skilled OR experts, Sri Sharan Pondarikapuran, Claude Philippe Medard, and Nidhi Soni. And we, together as a team, we put out this framework to address a problem we were facing with a customer that was using SAP IBP. And had some challenges trying to model a problem that wouldn't fit the constraints or the limitations of SAP IBP. Although SAP IBP is very powerful tool, it had some limitations in the sense that it could not handle some nonlinearities, for example, in the process. And we'll present the framework that we proposed to solve that particular problem. And let me go over what we're doing. So we're first looking at IBP itself in general. Part of the framework, or the key part at the heart of the framework, is data intelligence, a tool that allows you to, or customers to create pipelines, to ingest data, to orchestrate processes, to scale out these processes, and in a very flexible way, allowing to in this sense also integrate third-party optimization tools, which is what we've done there. I'll show an overview of what this framework looks like. So once you connect all the parts, the IBP, data intelligence, and the third-party solver, which in this case was FICO Xpress. Then I'll go into the specific instance of the problem. So this was presented in the context of an interaction with a customer, that the group, the SAP COE, the Center of Excellence for Data Science, is a customer-facing group. And we were presenting this, or we were challenged by a customer to solve this problem, this optimization problem. And the answer was this, example, or this modeling with a sample problem that captures most of the issues that they were having in a somewhat reduced setting. So in this case, this problem is then presented. I'll show you also a demo in the actual system, in showing DI and IBP. And if there's some time at the end, I'll present some other OR projects that are being done and scaled out in a production environment using that same framework. Okay, so regarding IBP, what is IBP? IBP is integrated business planning for SAP. The idea is to allow the user to combine stages of this business planning that were otherwise siloed. They happen very much in isolation of each other. IBP intends to facilitate the coordination of these different processes. The demand process, demand generation, or demand forecasting, for example, is a typical process. Then inventory optimization and so on. So synchronizing and reducing the siloing in these processes is one thing. Then also helping end-to-end visibility, since the users now have access to all these different processes in one tool. It allows the users to, or these different groups or entities, to talk to each other, to see the results of their processes and make use of them, and resulting in faster planning cycles overall. Inside the IBP, there are a few different modules or tools. There's demand planning, which is more of a, think of it as a forecasting tool or a forecasting functionality that allows users to create what typically comes in as an input to optimization. There's some sort of a demand plan or forecast that tries to understand what the market is requiring from a certain material. Then there's different modules like inventory optimization, demand-driven replenishment, and then more tactical response and supply, where you're trying to respond to changes on the fly. We will be talking here mostly about how we adjusted the sales and operation planning in general, which is a combination of this demand planning and inventory optimization. And when you talk about then sales and operation planning, the idea is to get out an optimal business plan for this supply chain. So you need to figure out how much you're producing of your finished goods, and how to balance your constraints in your supply chain, for example, in your capacity of production and so on, with the demand that you see on the market, while attaining some goals or KPIs, or optimizing some sort of KPIs, or like revenue or profit or some other important metric. What this looks like typically in IBP. So if you're talking specifically about the supply chain optimization, a simplified example would look somewhat like this. Sorry about that. You have some constraints around flow. So let me get my laser pointer here. So you have some plants producing material that has to be taken into some sort of distribution or even processing centers, and then have to be fed into some customers that have specified demand. In IBP, you are allowed to define some constraints at this. Your plants have a limited capacity of production. There are lead times, and there are also storage costs and so on, and other constraints, maybe capacity constraints on these nodes. And customers will have demand that are defined. And typically, IBP would allow you to cast this as a mixed integer programming problem. The challenge here, and that we're trying to address, the customer we were looking at had some issues where there were some transformation steps in the process where the material coming out of the plant, the raw material, will be transformed into final material in a non-linear way, and that unfortunately couldn't be put into or cast into mixed integer program. So that's IBP, integrated business planning. The key part of the framework. So IBP is just one example of one system that we can access to and to make use of these third-party tools like FICO. But the key part is data intelligence. And what is data intelligence? Well, data intelligence is, if you strip out the SAP naming, essentially it's a framework for creating pipelines and of containerized or containers, Docker containers, essentially running in Kubernetes. So not too different from other products that you might see outside, with the advantage that SAP wraps this up with integration in mind. So we are able to integrate back into our own systems. You can create this data pipelines easily integrating into, say, ABAP systems, for example. And in these pipelines, you can access and connect data, govern how the data is used, prepare this data, scale up and out these models that you create. It's very flexible in the sense that you can deploy models or executables, let's say, there are of almost any form, as long as you can put it inside a container. And then you can go through the life cycle of this model. So you can deploy it, integrate it, monitor, incorporate it, or orchestrate it inside your outside processes to be able to consume it. Sorry, let me move forward here. So what are these processes? So first, connecting and ingesting this data. We can connect streaming, structured, unstructured data. This data then can be used to create models. So we go to some sort of preparation or data engineering. You can run machine learning, or in this case, OR, in the example we are doing here, or some deep learning, or whatever it is that you put it in this container. And then you can scale that and deploying into a large scale. So you can deploy the models, monitor the performance, refine these models over time, enhance or even retire some of these models. And finally, you can put it in production to allow it to be consumed. So put it in production basically means automating those business processes and giving visualizations and so on, personalized interactions. So specifically, each one of these aspects or functionalities of data intelligence will give you a lot of flexibility. So that's the point of using it in this framework. And mainly we are focusing on the part that you can actually embed these custom processes. As in this case, we went through an embedded custom optimization solver in this process, in this pipeline, consuming data from our SAP system and then making it available back into that SAP system seamlessly in a way that a user could still be in IBP, integrated business planning, and not necessarily know that they are actually using this pipeline consuming the third-party solver. So the integration was full circle, and we would give back the results to the user in a seamless way, if you will. Okay. Okay, so what does this framework look like? At a high level, and for this specific instance, the way this looks like is that we have this IBP suite sitting on the cloud with all this different functionality, and on the other side we have the cloud, the SAP based, the SAP cloud platform. It's basically a cloud environment hosting data intelligence and connecting to the core SAP systems as for HANA. The data, then the user would trigger some sort of event here, an optimization event, and connect to SAP or trigger another event in SAP, where we would internally in these pipelines execute some third-party library. In this case, we use FICO Xpress to execute library. We would have the ability in this framework to capture data from external sources like data, other, whether in this case it's represented here, or any type of external indices or whatever is relevant for the problem. But the good thing is with SAP and this integration engine, we can put essentially any kind of custom algorithms in here. So we had another instance where we did some work. This is work that actually my colleague Claude has done, where a customer had their own executables. They were writing their own custom code for optimization. And the challenge there was being able to scale out that code in thousands of parallel jobs that would be triggered. And in that case, the way he approached it is was able to wrap that code inside data intelligence and successfully solve these problems very quickly, in a very efficient way. As part of the framework, of course, you also get additional benefit of using efficient databases like SAP HANA, for example, because you're able to connect to essentially anything here, any SAP system, or many different SAP systems, I should say. And SAP HANA itself comes with some additional engines that can be used to leverage any problem. Well, what's the specific problem that we were looking at in this situation? Oh, this was a production problem in a mining company. And again, this is I would call it a toy example, or an example that was used to demonstrate the capability of solving this nonlinear problem. They gave us this network where you would produce materials in a couple of mines. So this is an ore. These mines are producing ore of different qualities and different types of ore. And this ore flows through the network all the way to the final consumers. In this simple example, you had 3 consumers. We knew the demand, so there was a forecasted demand for these 3 consumers. And the key step in this processing was that there's a nonlinear metallurgical process that happens here in these mines, or in these plants that are processing the ore coming from the mines. And it's at its core nonlinear, so it really cannot be captured in a linear programming problem or mixed integer programming problem. And it had to be addressed with a specialized solver. What is that? So that's something related to smelting and refining. So basically, you might be mining for ores like copper, nickel, or cobalt. There's some process of this refining that's generating different kinds of byproducts, and some of these byproducts might be fed back into the system, and the nonlinearities then cannot be ignored, let's say. And there are also grades and types of materials that need to be taken into account. We haven't taken all of these into account in our model, but the model was enough to prove that we could handle the nonlinearities. So that was the idea. And we modeled that nonlinearity using the nitro engine inside Xpress. So for this simplified demo, what we have essentially this FICO Xpress, the Nitro model running inside Data Intelligence and connecting back to SAP IBP. So you get a request from SAP IBP, you model, and you optimize that request, you send the results back to IBP, and the user will then get these results. I'm going to go into the system itself, but just as a primer, this is what it looked like in the more scaled out version. So here we had some triggers saying you received some data from IBP. We were able, and that's one of the nice things of data intelligence, we were able to create an operator, a specialized container, apologies here, a specialized container that would run FICO, so it would consume the data coming from HANA, and it would then run FICO, run the optimization process, and send the data out back into HANA and create some reports to allow us to understand the results. And in the end, you get a result that, okay, possibly you have some specified demand, and the optimizer is able to satisfy the demand to some level. In some cases, maybe not even fully because of capacity constraints and so on. You can see in this case, it's an output you see in IBP. And I apologize, we didn't have an IBP system to access, so I'm showing you screenshots of IBP. But in IBP, the user would then see, okay, these are my capacity usage, for example, and this is how much of the demand I was able to satisfy. In some cases, it was maybe too extreme and I couldn't complete it. So I'm gonna switch now quickly to my framework here, if you don't mind. So let me then show you. This is what the framework looks like, or the DI, the data intelligence looks like this. Hopefully it's not too small to be seen. But this is a pipeline in data intelligence. So that's the pipeline that we are using here for the demo. We are on this simplified framework. We're just monitoring a table. We don't have an IBP system to directly to connect to, but we're monitoring a table in a HANA database, essentially in the HANA database. And once we see a change in that the table, we trigger this FICO operator. So this custom FICO operator, it's just in this case, for simplicity, we just made it as a Python code. And this Python code is just calling the command line executable for FICO. So if you go in and look at the details, it's taken into as input a Mosel file, which is a problem. So it's an optimization problem. So it's taking that problem as input and it's executing some Python code, which we can even go and take a look. Python's relatively simple. All that it's doing in the end is running a shell command. It's running FICO with that specific file. Um, so on the other side of the spectrum, there's the table, the database itself. And the database, for this example here, we're triggering the events just by adding another row. So if we add another row here, we'll see that process being triggered. And actually, before I do that, let me show you this. So I have my pipeline running here. This integration test is the pipeline. And if you then click on the pipeline, that will give me the actual instance that's running. So this is these are the actual containers that are running. And I can then go in and monitor. I have a terminal connected to the output of this process, and I can go and monitor the terminal. And I have ran an optimization earlier, so you see some results here. But if you pay attention here to the date, I'm going to kick it off again by changing a record here. So if I add another record on this database, it will give me some time and then outproduce. So it just produced another output, not right now. Yeah, so it created another output, and we can go up and see what is it doing. It's it's running Nitro. It was able to find the optimal solution. It was able to find a locally optimal solution in these many iterations, and then it gives me some output, tells me what happened here with my variables. So that's it for the framework. So that was this. So that basically was proof to the customer that we could solve it and integrate. So these results would then be fed back into IBP, and the customers were actually very pleased. Unfortunately, that specific project still hasn't gone forward. The customers, the different departments, but another department of the customer did go forward with a similar project, where my colleague Claude Philippe actually has done a lot of work. And just very briefly talk about it. So this idea is actually in the same system. They have this big production network, and they have to do maintenance on this production network. And the network itself consists of 500 different assets that have to be maintained, different points in time. But the key point, as you might think, this is a huge flow of goods through this network, and relatively narrow. There are not a lot of options, and they have to minimize outage time. They don't want to have the network clogged or stopped because of outage. And they define assets that have to be stopped together, or they may not be stopped together. And there's also the obvious limitations of maintenance of some of these things, because they're maybe physically collocated and so on. And they asked us to then find a solution that would minimize the total outage time. And for that, I'll just switch again to my example here on the data intelligence. The pipeline that was created, so this was what Claude did. The pipeline created would then need these 500 assets would in the end decouple, but because they had different zones, you would be able to decouple these assets, even though there were some maybe that have more constraints than others, etc. But you would be able to decouple these 500 assets and spin out smaller instances of optimization problems. So the solution then, the way it approaches, it gets a request for optimization. It sends out a number of different requests, which are for these independent optimization problems. And SAP Data Intelligence can then spin out all these parallel options at the same time, or the parallel container instances at the same time, which will run in parallel and produce the results very quickly. And that's so that's pretty much what I had for this. So I'll open up for questions. Let me put it on this final slide. But that's again, that's work done in together with other colleagues, and we're happy to answer any questions here now or offline if needed.